Welcome to Pre-Calculus. Today we will investigate describing angle measures. We'll take a look at 6 examples. First examples, I want to just find the measure of a given angle from a diagram. So my first diagram here, I see I've got the angle represented by this red spiral. Now, first thing I need to note is that this angle is going to be measured in degrees. I've got some measure there, 75 degrees between my angle and this y-axis. So just to orient ourselves on the coordinate plane with the angle measures, we just need to note that we start here at the positive x-axis. That would be 0 degrees. We call that standard position. Now, let's just say what the increments for my angles would be as I head counterclockwise. So first of all, counterclockwise is the positive direction. And what we can do is mark the 90s. A lot of times the 90s are helpful. So if I make a 90-degree turn counterclockwise, I would note that 90 degrees is here at the positive y-axis. If I continue on counterclockwise, the negative x-axis would be 180 degrees. And then keeping in a counterclockwise direction, the negative y-axis would give me 270 degrees. And then to round out that full rotation would get me back to 360 degrees. And in fact, 360 degrees is equivalent in terms of position to 0 degrees. And then we could keep going. So we see that with ours. And I'm going to use our diagram here to help us find the measure of this angle in our first example. So I'm just going to note that if I travel once in a full rotation, so I am starting counterclockwise, that's the positive direction. One full rotation would be 360 degrees. So I'm going to treat it in parts. That first full rotation is 360. Now I want to consider starting again in the counterclockwise direction. So I'm going to go a full 180 more. And then I've got a small portion left that's underneath this negative x-axis. Now, I don't really know what that extra part is, but I can find it using the given 75 degrees between our side of our angle here and the negative y-axis. So I know that full quadrant is 90 degrees. So all I'm going to do is take 75 subtracted out of 90, and that's going to give me a difference of 15 degrees. Now, for me to find the measure of this angle, I just need to add up those 3 measures that I've found from the pieces of the rotation. So the first rotation full circle is 360 degrees. And then we'll add to that the half rotation that continued on to 180 degrees. And then add our 15 degrees to those 2 measures. So we're going to add all those up. That's going to give us a 5. 6 plus 8 is 14. 14 plus 1 is 15. And then 3, 4, 5. This is a 555 degree angle. So with that first example, we're measuring in degrees. Now, another major way to measure angles is using radians. And let's start off again. So in example 6, I have my angle measure that's given here in the diagram in radians. And I know it's in radians because it involves pi. And notice there's no unit on it. Radians is famous for not having a unit. So let's just describe the coordinate plane in terms of radians. We did so with degrees in our first example. So where we'll start again is standard position at 0, but notice I'm not putting degrees on that. I'm just saying it's 0 radians. Now we go up by 90 degrees. So the equivalent radian measure for 90 degrees is going to be pi over 2. So if we're headed in the positive direction, which again is counterclockwise, my first quarter would be measured as pi over 2 radians. If I keep going, I'm going to think pi over 2 plus pi over 2 is going to be 2 pi over 2, or just pi. And that would be, again, equivalent to 180 degrees. I'll keep going in the counterclockwise direction. So if I add pi over 2 to 2 pi over 2, that's going to be 3 pi over 2. And then to round it out, if I add 1 pi over 2 to 3 pi over 2, that's going to be 4 pi over 2, or 2 pi. So that would be like our 360. And we could keep going. So let's check out our example here. So we'll do the same thing as we did in the first example. So I see we're going in the counterclockwise direction from standard position. So I'm just going to mark one full rotation, and that's going to be 2 pi radians, again, equivalent to 360. I'm going to pick up then with this portion that's above the x-axis. So it's still moving counterclockwise. That's positive direction. And that piece is equivalent to pi over 2 radians, or 90 degrees. And then I see that the part that's left, this small angle from the 90 degrees, or the pi over 2 counterclockwise, has a measure of pi over 6. So similarly to what we did in the first example, I just want to add these 3 parts. So it's the full rotation 2 pi plus that quarter rotation pi over 2, and then plus that small additional rotation pi over 6. Now with degrees, we can just add the numbers up. Radians are predominantly fractional. They're rational numbers. Well, irrational because they involve pi, but pi is included a lot of times in a fraction. So what I need to do is get these denominators the same. So the denominators all need to be 6. So I'm going to call 2 pi 12 pi over 6. That's just scaling that fraction so it has denominator of 6. Similarly, pi over 2, I'm going to call 3 pi over 6. And again, I just can see, because I multiplied the denominator by 3, I multiplied the numerator by 3. Similarly, for 2 pi over 1, I multiplied by 6. And then for my third fraction, it already is over denominator 6, so I'll just write pi over 6. And to evaluate, all I need to do is add up my numerators. So that's 12 plus 3 plus 1, and that's going to give us 16 pi over 6, which I can then simplify by dividing out a 2 from the numerator and denominator to give us final answer here of 8 pi over 3 radians. So again, notice you don't have to write units. It's understood if it involves pi and we're talking about angles, that's going to be a radian measurement. Our third example is really the reverse task. In the first 2 examples, we had an angle drawn that we wanted to find the angle measure for. Here I have the angle measure. I want to draw the angle. So the angle measure that I've got here is negative 3 pi over 4. So just to help us visualize again the radians, notice first of all that this is the negative direction. So we know that we won't be going counterclockwise. Negative direction is clockwise on the coordinate plane. Let me write here negative instead of the negative sign. Now, to help me out with just marking the increments, I do want to note, because we did pi over 2 for the 90s when we looked at it at first, but this is over 4. And what that would be equivalent to, if I'm just considering the positive direction, is 45 degrees. So pi over 4 would be 45. We can mark this within our 90s though. So pi over 4 plus pi over 4 would be 2 pi over 4 or pi over 2. So that one we had seen already. If I keep going with the 45s, this is going to be 3 pi over 4. And then 180 degrees, or pi, is going to be 4 pi over 4. And that even reduces down to just pi. Continuing on, just so we can catch these, 4 pi over 4, 5 pi over 4. 6 pi over 4 would reduce to 3 pi over 2. 7 pi over 4. And if I add pi over 4 to 7 pi over 4, that'd be 8 pi over 4, or 2 pi. So that helps us kind of visualize where we need to go. Now, I do need to get the negative direction. So I've got that marked. It's clockwise from standard position, the positive x-axis. And basically, if I'm going negative 3 pi over 4, if I mark here on my plane the 45s, which again are each worth pi over 4, we're just going to go for 3 of them. So my angle, I'll draw it here in green, is going to be 1 pi over 4, negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. And that is complete. We've drawn our angle. And let me label it negative 3 pi over 4. Our fourth example is a similar task, but notice it's now given in degrees. So we're trying to draw an angle with the given measure in standard position for 370 degrees. So just again, to reinforce this idea of standard position, we are beginning at the positive x-axis. So for this degree measure, remember the full rotation was 360 degrees. So as I start to draw my angle, I need to go a full rotation, that's 360. And then I need an additional 10 degrees. So I know that the full quarter here is 90 degrees. So I really need to split this into 9 parts. So I'm going to cut it into thirds, and then each third I'll cut into thirds. And what that gives me, let me go ahead and mark the terminal side here, is 10 additional degrees. And I would just continue the rotation past 360, 10 more degrees, and that's going to give me 370 degrees in the positive direction. Again, positive for us is going to be counterclockwise. Our last two examples involve us finding reference angles. So we talked a little bit about standard position, and reference angle is related to the idea of standard position. Basically, a reference angle, let's define it in words and then we'll mark something on our diagram, is the smallest angle measure that a given angle makes with the x-axis. So a reference angle is the smallest angle measure a given angle makes, not in, but with the x-axis. So let's just mark a few examples here of reference angles. So say we're on our plane and I have an angle, for instance, I don't know, let's say that that's roughly 200 degrees. We'll just say that's 200 degrees. So the nearest angle that I could make with the x-axis would be going back to the negative x-axis. I could also go to the positive x-axis, but that wouldn't be the smallest angle. The smallest one is going to be this one between 200 degrees and that negative x-axis. So the reference angle here is really, what's that small angle? So that would be 200 minus 180, that's 20 degrees. Well, let's find for our angle here. So we've got the measure 140 degrees. So I'm going to sketch the angle first, just so I can see where it lies. So here starts on standard position, and we're going to go 140 degrees. So we're going to go 90 degrees to start, and then we need 50 more degrees. So I'll go ahead and draw that terminal side of the angle. So there's our 140 degrees. So it helps to visualize, to sketch it. And I see that the smallest angle that 140 degrees makes with the x-axis is going to again be to the negative x-axis. Now, once I've got that drawn, again, I just need to say that's 180 degrees. So between 140 and 180, our reference angle is going to be 40 degrees. Our last example is given again in radians. So here we're looking at an angle measure of 9 pi over 4. So I just want to think about this in terms of how I would rotate. I know a full rotation is 2 pi, which if I put it in denominator of 4, 2 pi is going to be equivalent to 8 pi over 4. So what I see here is I've got that full rotation plus, if I subtract 8 pi over 4 from 9 pi over 4, I've got 1 pi over 4 additional. So the way I want to think about this radian is really with the full rotation and then whatever's left over. So just like we did with the degree measure, I'm going to sketch it first. So 9 pi over 4, again, we're going to go a full rotation 2 pi or 8 pi over 4. And then I've got one more additional rotation or part of a rotation that's pi over 4, which you can recall is equivalent to 45 degrees. And when I draw that in, that second piece would give me my full angle, 9 pi over 4. And I can see that that additional piece right there is in fact my reference angle. That is the smallest angle between my terminal side and the x-axis. So kind of just by sketching the angle, we see that our reference angle for this example number 17, 9 pi over 4, reference angle is going to be pi over 4. The smallest angle that that terminal side makes with the x-axis. Thank you for joining for these examples of describing angle measure. See you soon.